Okay, so now let's take a look at a trig equation that involves doing some substitutions with the identities. Okay, so we're going to take a look at cosecant x is equal to the square root of 1 minus cotangent x. Okay, so for 1, we are solving an equation that involves a radical. What have you done in the past in that situation? We'll isolate the radical, square both sides, and see what results. So I'm going to do that here too. But please note, when I'm solving an equation that involves a radical, I have to check solutions because I'm going to modify the equation as I solve it. So I have to check these solutions. I do have the possibility of extraneous solutions. Okay, so I'm going to square both sides. When I square both sides, I will get cosecant squared x is equal to 1 minus cotangent x. Okay, so when I have a squared function, remember this is when I said, okay, it's helpful to set it equal to 0 and see if it will factor. However, if I pull these two terms to this side, I'm going to have two different trig functions on the left. I'll have cosecant and cotangent, so I'm not going to be able to factor anything out. So in this case, it'll be helpful to make some kind of substitution to try to manipulate all the same function throughout the equation. So remember, when you see those squared functions, it's helpful to think about the Pythagorean identities. So this is where your trig formula sheet will come in handy. So it's good to think about, you can kind of scan these. Like you might be solving an equation in a different example that involves, one of the functions of the sum of angles, in which case you could make a substitution. You might be solving for a double angle, in which case you could make a substitution, or a half angle. In this case, I am solving for a squared function, and I know that the Pythagorean identities relate cosecant and cotangent. So I'm going to replace cosecant squared with 1 plus cotangent squared, and that's going to make solving a whole lot easier. So again, I'm going to replace cosecant squared with 1 plus cotangent squared. So now I have this I have the same trig function throughout the equation. So now let's go ahead and set it equal to 0 and see if anything will factor. So if I subtract 1 from both sides, 1 will 0 out. So I will have cotangent squared plus, don't forget the x, plus cotangent x is equal to 0. Now just like when I'm solving for a squared function, I'd see if I could factor, which I can. I can take out a cotangent x, and that leaves me with cotangent x plus 1. So now set each factor equal to 0. So cotangent x equals 0, and cotangent x equals -1. So now I will solve both of these equations. So when is cotangent x equal to 0? Well, again, that 0 makes me think on my cheat sheet about the unit circle. So when is cotangent, which would be the x over y, equal to 0? So that would be when I have a 0 in the numerator. So when x is 0 would be at pi over 2 and at 3 pi over 2. So cotangent of pi over 2 is 0, and cotangent of 3 pi over 2 is 0. So this would be when, So this would be when x is equal to pi over 2 and 3 pi over 2. Now when is cotangent x equal to -1? Okay, well, I know, again, thinking cheat sheet, So both tangent and cotangent of pi over 4 is going to be 1. So since it's negative 1, that means that I'm going to have to think about, sorry about that, I'm going to have to think about when is cotangent negative. Well, it's going to be negative the same places that tangent is negative. So it's negative in this quadrant and in this quadrant. So my reference angle, again, I know that cotangent of pi over 4 is equal to 1. So my reference angle is pi over 4. Because again, I know that cotan from that triangle of pi over 4 is equal to 1. But I want to find the angle in quadrant 2 whose reference angle is pi over 4. And the angle in quadrant 4 whose reference angle is pi over 4, since we're looking for when cotangent is equal to negative 1. So again, to find this angle, I would think, okay, let's, instead of thinking of pi, let's think of 4 pi over 4. So if I subtract pi over 4, this would be 3 pi over 4. And instead of thinking about 2 pi, think of it with a denominator of 4. So this would be 8 pi over 4. So if I take away a pi over 4, that would make this angle 7 pi over 4. So cotangent is equal to negative 1 when x is 3 pi over 4 and when x is 7 pi over 4. All right, so if we're solving, again, just within one revolution, so from 0 to 2 pi, then I have these 4 solutions. But remember, I have to check these because I do have a possibility for extraneous roots. So we have to go back to the original equation to check. So let's check x equals pi over 2 first. So when x equals pi over 2, let's do the check. So I would have cosecant of pi over 2 is equal to the square root of 1 minus cotan of pi over 2. Okay, so cosecant of pi over 2. Okay, think about, again, your little cheat sheet. All right, so here's pi over 2. Cosecant is 1 over sine, or 1 over y, so that would be 1. So I would have 1, I hate when it does that. 1 is equal to the square root of 1 minus what is cotangent of pi over 2. So again, take a look at your cheat sheet. So cotangent is x over y. So here's pi over 2. X over y would be 0. So I do have 1 equals the square root of 1, or 1. So pi over 2 is a solution. All right, so if I check 3 pi over 2, so I would have cosecant of 3 pi over 2 is equal to the square root of 1 minus cotangent of 3 pi over 2. Okay, so cotangent or cosecant of 3 pi over 2. Again, if I consult my cheat sheet, I will find that it's negative 1 is equal to 1 minus cotangent of 3 pi over 2. So if you think about cotangent of 3 pi over 2, again, cotangent is going to be y, or x over y, so that's 0. So I have negative 1 is equal to positive 1, so that's a no. So x equals 3 pi over 2 we have to throw out. So now I would do the same thing with x is equal to 3 pi over 4. So cosecant of 3 pi over 4 is equal to the square root of 1 minus cotan of 3 pi over 4. So, okay, so now I'm thinking 3 pi over 4. So this is a special triangle. Cosecant of 3 pi over 4 is positive, right? Because that would be in quadrant 2, where sine and cosecant are positive. So this would be with a reference angle of pi over 4. So again, consulting my cheat sheet, I can see that this is the square root of 2, right? Because I would be looking at the 45 triangle. Cosecant would be hypotenuse over opposite. So that's just square root of 2. Equals the square root of 1 minus, and then cotangent of 3 pi over 4. Again, if I consult my triangle and consider that cotangent is negative in quadrant 2, this would be negative 1. So I would have the square root of 2 is equal to the square root of 2. So that one checks. And then last but not least, if we check cosecant 7 pi over 4 is equal to the square root of 1 minus cotan of 7 pi over 4. Okay, so again, here's my 7 pi over 4. So cosecant is going to give me a negative value. So again, that would be negative square root of 2 is equal to, so cotangent is also negative in quadrant 4. So this would be 1 minus a negative 1. So negative square root of 2 is equal to positive square root of 2. So again, this one is a no. And I would throw out 7 pi over 4. So I have 2 solutions on this interval, and that would be just pi over 2 and